Alright guys, so this video is going to review some domain and range. Okay, so if we look at example 1, notice that this is a discrete function, meaning that it's just like dots along the way. It's not continuous. There's no line that we can draw that follows this graph, if you will. Okay, so I'm going to go ahead and just write the coordinates of each of these. So this is what? -3, -4. Okay, this one right here is -2 and 5. This one right here is 1, 3. This is 1, -2. And this one here is at 4, 0. Okay, so this graph consists of 5 points, and here are their coordinates. Okay, so remember the domain, go with the x coordinates, and the range goes with the y coordinates. Okay, so notice when these aren't continuous, our x coordinates, we will write them as a set, meaning we have these brackets like this. And usually we write it from least to greatest. So all I'm doing is looking for these values here, because domain is determined by the x coordinates. So -3 is the least. And I'm going to cross it off just because we used it. -2 is the next least. Okay, then we have 2 1s. I only have to list that once though. And then we have a 4. And that would be our domain. Okay, now our range is our y coordinates. So we're looking at these points now. And once again, we want to write those in increasing order. So we want to start with least to greatest. Okay, so notice that our -4 is our least. So I can -4. What's our next least? -2 is our next least. And then I have 0, and then 3 and 5. And so that would be our range. Okay, now when I'm asking if it's a function, what we need to look for is the vertical line test. Okay, remember a vertical line is up and down. So this tells me if I can draw any line anywhere on this graph straight up and down, if it crosses the graph in more than one point, it is not a function. Okay, so if I look here, if I draw this straight up and down, we'll pretend that that's straight up and down. Okay, that would be the x = 1 line. Okay, we're going to pretend that's straight up and down. Notice if I do that, I intersect the graph at this point and then also at this point. Okay, so because I intersect the graph at more than one point, no, this is not a function. All right, so let's look at example 2 here. Okay, now this is a continuous function. Okay, we're not just dealing with a bunch of dots. Okay, but notice I am very confined in both my x and my y's. All right, so think I could draw a line here. Okay, actually, let's see if I can highlight that. Nope, my highlighter doesn't want to work. Oh, there it is. I can draw a line here. I can draw a line here. Okay, I can draw a line straight up and down here. And I can draw a line straight up and down here. Okay, and notice this box that I've created in the middle, so like this box, this box, this box, and this box, that box contains every point on that graph. Okay, so remember, if my domain is my x values and my range is my y values, well, my x values start at what, -3? And every single x between -3 and +3 is in there. So I'm going to say x is less than or equal to x, which is less than or equal to 3. Okay, so every x value between -3 and 3 is somewhere on this graph. Okay, and the reason it's less than or equal to is because, yes, x equals -3 here and x equals +3 here. Okay, so with that same mind, my range is my y value. So my y goes down here from -4. So -4, and yes, we are equal to -4. So I'm going to say is less than or equal to y, because range is the y, which is less than or equal to, well, the top value is 3 up here. So -4 is less than or equal to y, which is less than or equal to 3. Okay. Now, once again, is it a function? Okay. Can I draw a vertical line anywhere in this graph to where it intersects this at more than one spot? So let me draw a vertical line right here. Okay, at what, x equals -1. So notice when I do that, I cross at this point on the graph and also this point on the graph. And because I cross at more than one point, I can say, no, this is not a function. All right, let's look at example 3. We have a couple things I want to talk about here. Okay. First of all, we notice this open circle. Okay, what that means is that it's not equal to. Okay, and then I notice this arrow here, right? The arrow, and that means it goes forever. Okay, so once again, if I draw my box, okay, well, I'm not to the left. Let's see if I can get a highlighter. I'm not to the left of here. Okay, I go no lower than right here. I hit it, but I don't go lower. But then notice this arrow here, I continue to go up and up and up and up and up. Okay, so I'll go to infinity all the way up, and I'll continue to go right and right and right and right and right. So I'll continue to go to infinity on the right as well. Okay, so when I write this, remember my domain is my x values, my range is my y values. Okay, so notice I start at 4, or at -4, I'm sorry, right here. I start at 4, but I am not equal to -4 because that's what that open circle tells me. So I'm going to say -4 is less than, and we're strictly less than, we're not less than or equal. -4 is less than x, which is also less than. Now I'm going all the way to infinity. I'm going all the way right. So I would say infinity. Now, from a theoretical standpoint, I never reach infinity or negative infinity. So anytime you have infinity, it'll always be less than or greater than or whatever. It'll never be less than or equal to or greater than or equal to. All right, let's look at my y. Okay, now very clearly my y, I'm going looking for up and down. I start here at y equals 1, and I do equal y equal 1 in this part of my graph between my 1 and 3 x values. Okay, so I could say that 1 is less than or equal to y, which is less than, and once again, I continue going up and up and up. This arrow tells me I'm going to go higher and higher and higher and higher and higher, and I'm just going to continue on. So that's going to be less than infinity. Okay, now notice on these, I'm going smallest number on the left, biggest number on the right. Okay, you want to keep it in that order. Notice on my domain, I always have an X. My range, I always have a Y. That should always be the case as well. Okay, now, is this function a domain? Or, sorry, is this a function? So if I look at this graph, nowhere on this graph can I draw a vertical line that intersects it in more than one spot. Okay, any of these lines, I just cross it once. Okay, so because of that, I can say, yes, this is a function. All right, I want you to pause this video right now and try to do this one on your own. Okay, if you're stuck and you don't know where to start, look back at number 2 because it's very similar to you, but pause it, start it, and then we'll review it. All right, so hopefully you tried this on your own. Okay, so if it helps you, highlight what I did in purple to kind of box in this circle, and I actually colored in the box that it blocked the circle in. Okay, so our domains are x values, and this is continuous, meaning that there's no holes or gaps. Okay, so notice my x value starts at -2, and it does equal -2 right here. So I can say -2 is less than or equal to x, which is less than or equal to, because we equal 2 right here, 2. So that's my domain. Okay. My range, now I'm looking for my y value, so I start down here at 0, And I do equal 0 right here at 0, 0. So I can say 0 is less than or equal to. And once again, we're doing range, so it's y, which is also less than or equal to. I stop right here at, what is that, 4? So that's 4. Okay. Now, is it a function? Well, no, it is not a function because I can draw this line here, okay, or several other lines, and it crosses right here and right here. So because it crosses it more than one place, it is not a function. So I'm going to write no. All right, let's look at example 5. Okay, now this one, like, don't overthink it. Okay, so this is just a line, and this arrow tells me I continue left and I continue down forever. Okay, and then notice I have another arrow over here that tells me I continue up and I continue right forever. Okay, so there's absolutely no restrictions. There's no holes in this graph. It continues on. It's continuous. So I would just say in our domain that negative infinity is less than x, which is less than infinity. And remember, when we go to infinity or negative infinity, it's always strictly less than and never less than or equal to, because out of a technicality, we never get there. Okay, and then range is the same thing. We're going all the way down and all the way up. We have no limits. So I could say negative infinity is less than y, which is less than infinity. And is it a function? If I draw any line anywhere, it's only going to cross it at one spot. Okay, any of these lines, only going to cross it at one spot. So I could say, yes, this is a function. All right, so using example 5, I want you to try to do this on your own. So go ahead and pause it, try it on your own, and then we'll go over it. All right, so hopefully you've done this one. Now, when you look at this, the only restriction you have is down here at the bottom, okay? It doesn't go below this line. But this arrow right here says we'll go forever left and forever up. And this arrow right here says we'll go forever right and forever up. So as far as left and right, we're going on forever. So I could say negative infinity less than x, which is less than infinity. And my range, the only restriction I have is I can't go past this -5, but I'm equal to -5 right here. So I can say -5 is less than or equal to y, which is less than infinity. Remember, we can't be equal to infinity. And then, is it a function? Well, no line, no vertical line can I draw that crosses this in more than one spot. So that means, yes, we are a function. All right, use example 6. Pause this and do example 7 on your own. All right, so if I look at this one, the only restriction I have is that we don't go leftward beyond this x equals 0 line. So therefore, my domain is 0 is less than or equal to x, but I go on forever to the right, so it's less than infinity. Okay, my range, on the other hand, I don't have any restrictions on up and down, so just negative infinity is less than y, which is less than infinity. And then is it a function? Well, right here where this is red, we cross it in 2 different places, so no, it is not a function. All right, so let's look at this one. This one's kind of a funky looking one, but we do have some. So when I'm talking about my x values, I'm starting here, okay? Notice I don't equal here, and I go on forever to the left. Okay, so I can say that negative infinity is less than x, which is less than, it's not less than or equal to, it's less than 2. And the reason it's not equal to is because that open circle. But notice we have an open circle right here too. So we have to put comma, x is not equal to -3. If we don't add this, that means that that's a closed circle, and that would be wrong. Okay, now as far as up and down goes, we have a restriction on our y right here. Okay, we never go under this, but this tells us I go forever up. Okay, so I can do my range as my y is never less than -2, so less -2. Now, just because my y is not equal to -2 here, it is here. So it's less than or equal to y, which is less than infinity. And then any line you draw Yes, it is a function. It does not cross it more than once.